Today, these are the main elements that are involved. Hydraulic jacks doing the work, the suspender ropes that are tied on to the main cable, and then the temporary works are what's holding the bridge right now. That's where we're transferring the load from. So basically, the operation is going to be pulling that main cable into place and lifting the bridge up. Now, the process for building a self-anchored suspension bridge, if you keep it moving, Paul, we had to place false work or temporary works. This is much bigger than false work, which is normally wood, that were about the size of the existing Bay Bridge. So we had to build a bridge. We had to build two bridges in order to get this one together. So that was done, and then we placed the deck segments one by one. There's 14 in each direction, a total of 28, and the tower section had to be erected as well, and 5 different lifts. The tower is actually made up of 4 independent legs, so you can think of it as a stool almost, that all had to be put in place. Once that was in place, we could go to the placement of the main cable. A footbridge had to be erected so we could put our craftspeople up there to help get the main cable in place. And then cable bands, which are the saddles that we will have the suspenders actually going around. 114 of them had to be placed out on the cable, and then the suspenders themselves had to be put in place, connected together, and then we transfer the load. That is what we're here to talk about today. That is the operation that has begun out on the San Francisco Bay. And of course, once the load's been transferred, we will remove all of the temporary works, and we'll have our new bridge. So now we're going to run through the simulations. And we're going to go back in time a little bit. This is the area that we're talking about. This is our self-anchored suspension bridge, Yerba Buena Island. So some of the operations that we already went through. Well, we had to pull the tower back towards Yerba Buena Island so that when it came the time that we were loading this thing, we could release it so that it didn't bend in the opposite direction. Then we had to place the cable, and that was no easy feat. This is the first time this operation had taken place. We had to use 2 different hauling systems to pull basically strands, 137 strands. Each strand contained 127 wires all the way around the bay and back to the eastern side of the span. So there you can see that's what the main cable is made up of. These strands, each one of those strands has 127 wires, 17,399 total. Then once that's in place, you don't have that perfect cylindrical form, so we have to compress it. We use compressing machines from the top of the tower, ran them down so that we could get rid of the voids, the spaces that are in between those, and compress it into a strong cable. Then you saw a little shot of the anchors. They're plated over. And then the cable bands. There are several different types of cable bands because they're at different places on the main cable that allow the suspender ropes to hang over the top of them. Each one precisely engineered to allow for the motion that's going to be taking place with load transfer. Then you got to get the suspender ropes in place. This is one of the ways that we did it. The ropes, the wire ropes, arrive in spools. They're lifted over the top. Now, we have not animated people in this, but several crafts are working here, iron workers in particular, to make this all happen. There's a lot of other equipment, but this is the basic concept of what we did to get the suspenders in place. About 200 suspender ropes on 114 different saddles make up this bridge. And then the suspender ropes are connected into our jacking mechanism. Then we're ready to move into load transfer. Now, load transfer is complex. Paul, if you can pause it right there. Basically, again, what we're talking about today is taking the weight off of the temporary bridge that we had to build and placing it onto the cable system. That's as simple as it gets. We have to do this, though, go ahead and run it, Paul, in 3 phases. So the first phase, which is what we're at right now, our contractor and engineers have very carefully selected 114 different ropes. Then the second phase has these ropes that are close to the tower, and then the third phase, the final ropes that are distributed throughout the system. At that point, all of them have been connected, all of the load has been transferred, and what Dr. Maroney will tell you is that the first set of ropes are going to be, Paul, if you can pause it right there, are going to be handling the largest loads that they will ever see right here at the beginning during this operation.
You can't lift this superstructure up off those temporary towers. You can't lift that without starting to load up the superstructure. So what you're lifting up is actually moving, right? So this heavy lift that Barton just described, it's a moving lift as it's going on. Plus, the tower that the cables are tied to, we're going to be managing that moving. American Bridge Floor, the company that's doing this for us, okay, they're managing that moving too. Okay, this is a shot where we see the contractor has pulled over the system, and would you pause please for me, Paul? Okay, what the contractor's done is the suspenders are up, as Barton described, they're hanging, and there's been a system of jacks and rods and connection devices onto the cable, and what they've done is they've lifted the cable pulling system up into the ropes, connected onto them, and then hydraulically down here pulled those rods and that cable over. Now what it did is it moved the main cable over, and the main cable moves about 10 meters. It translates about 10 meters. So I was trying to describe that everything's going on all at once. Okay, what we're trying to do is lift this box up off of these temporary works, but we're also having to do that by pulling against the cable. And the cable, even though it's very, very strong, over 17,000 wires, each one of those wires is 5 times the strength, more than 5 times the strength of regular 50,000 KSI steel. So this is very, very strong, but it's still flexible. So this cable moves a lot, many, many, many feet, just to get this to go up a few feet. Here's a shot where you see the same thing, just a close-up. These are the rods. These are temporary. These are the permanent suspenders that are coming down. They're 2 400-ton jacks that are being worked, reset, worked, reset, worked, reset as they pull. Okay, there's the rods. Okay. These are the wounded suspended wire, suspended rope. Okay, this is the end block. These have a hole in them. A threaded rod goes in and nuts go on the bottom to lock it in. Okay, the shims go in. We lock it into place. This is a shot while this is all going on, if you were underneath, as the box is coming up on the order of, it varies. Some locations near the tower, it's not even going to lift up off the temporary works. Other places, it's going to lift up as much as a meter separating between the two. On average, something like half a meter up. Okay? While the cables are moving, Bart, I always like to use metric, but you have the English imperial numbers memorized. 30 feet by 16 feet, right? One way over, one way down. Okay? Now, underneath the bridge, I described to you that the box is actually going to be shrinking. It's going to be, it's not shrinking, it's elastically shortening. Now, underneath, we can't connect the new E2 pier, that's the eastern pier on the east end of the SAS. We can't permanently connect it yet because we've got to allow for that shortening. Okay? So what we have to do is we have to not connect it, okay, until after it's shortened, and we've got some temporary sliding systems. Now, way back on the other side, on the west side, we want to have, as we tighten and load transfer, we want to have a nice, even distribution of load in that cable. So we've got a jacking system on the west end to push out the cable, hydraulic jacks here and here, and these are shims. So as these jacks push it out, we put in spacers, shims, and then once we have it to the right space, then we put reinforcing steel, cast it in a rock, and it's set forever. That's going on simultaneously. All these things have to go on simultaneously. Up at top of the tower, as the tower moves, okay, these are the tie-back cables. Okay, we have to adjust for that flexibility up at the top, constantly managing as load gets transferred.
But what do you take away from this discussion? There are a couple of key points. One, this is a very large milestone for the Bay Bridge. It's one that we've been waiting for a number of years. And it's been very carefully engineered to ensure that it is done correctly. Two, there has been a notice to mariners out for a long time not to go under the self-anchored suspension bridge because a number of operations have been taking place. We are strengthening that message to boaters right now. Individual pleasure craft should not go under this bridge during this time. We have the best engineers in the world working on this job. We have the best third-party review that's possible on this job, and we are going to do big things.